Guys, don't use substitution. It is very stressful and time consuming. Let us learn a very smart trick to solve this Olympiad challenge. We need to make use of these given variables to get our unknown variable. And how do we do that? We need to make use of a brilliant algebraic identity. Now let's recall that x plus y plus z all squared gives us x squared plus y squared plus z squared plus 2xy plus 2xz plus 2yz. So this means that if we can square this, we can extract the given variables from it. But this is not an equation, it is an expression. So we can't just square it arbitrarily. Now, for us to do this, we have to rewrite this expression as x plus y plus z all squared, then take the root. Because mathematically squares cancels roots, so we still have x plus yz. Now therefore expanding this using our algebraic identity, x squared plus y squared plus z squared plus 2xy plus 2xz plus 2yz and the roots. And now from the system of equation, we are given the values of xy, xz, and yz, but now we are left with the values of x squared, y squared, and z squared, which we don't know. Now we need some extra steps to get the values of this. First of all, let's rewrite the equations. So we have xy equals 10, then yz equals 20, xz equals 30. Now let's name this equation 1, equation 2, and equation 3. Let's multiply equation 1 and 3. So we have xy times xz equals 10 times 30. Then this will give us x squared times yz equals 300. Solving this, we have x squared times 20 equals 300. Divide by 20. Therefore, x squared equals 15. Now doing the same thing for equation 1 and 2, we have y squared times xz equals 200, and xz is given to us as 30, so we have y squared equals 200 divided by 30. Therefore, y squared equals 20 over 3. Doing the same thing for z, let us multiply equation 2 and 3. Therefore, we have z squared times xy equals 600. Z squared equals 600 divided by 10. Therefore, z squared equals 60. Now that I've gotten the values of x squared, y squared, and z squared, we can now substitute them into our identity. So we have 15 plus 20 over 3 plus 60 plus 2 into brackets 10 plus 2 times 30 plus 2 times 20, then square root of this. Then by simplifying this, we are going to have 20 divided by 3 plus 15 plus 60 plus 20 plus 60 plus 40. Square root of this also. Then by adding this up, we have 20 over 3 plus 195 and the square root of this. Now by adding this fraction, we have 605 all over 3, then square root of this. We can rewrite 605 as 121 times 5, then over 3, square root of this. Then we have 11 root 5 over root 3. Then by rationalizing, we have times root 3 times root 3. And our final answer, therefore, 11 root 15 all over 3. Correct.